So this is binary search. So with binary search, what basically happens, think about if a teacher was to, search for a book of a student and assume that those books were arranged in alphabetical order, yeah, or sorted according to sorted alphabetically. So rather than, if there are 300 books, rather than go one by one, you could first take away, like half of the books, then check if the middle one are the letter is or before or above. So the idea of a binary search is like divide and conquer, where you divide the data set by 2 and then check whether the data you're looking for is in in um in half of the remaining array data set. So the key to this is that the data set must be sorted, uh, yeah, either ascending order or descending order, yeah, but it must be sorted. If it's not sorted, then there is no point in doing a binary search, yeah. So just looking at this, assume we have data like this. Okay, so assume we have data like this. Sorry, it's so when you look at this data set, you can see it is arranged in alphabetical order, in ascending order. It is sorted. So I attached indexes 0 to 9. So the key thing is that with binary search, you divide by 2, and then get the middle index, yeah. So looking at, and with like any algorithm, we first determine what are our inputs. So we have a sorted array and then the search value. Our search value is going to be 59, and then the output should be the index of the search value, right? So if we are to follow through, our first index is 0, our last index is 9. So that's our first 0 and 9. So if we are to get the midpoint, 0 plus 9 is 4.5. So we go with the modulus, which is 4, because we don't work with decimal places. So 4 will be our midpoint, our mid index. So once we have our mid index, we will have 3 cases. The first case is to determine the value we are looking for, which is the search value. Is the search value equal to the value at the mid index? So the value at the mid index is 25. So it can either be equal. So if it is equal, then we will have found it. We stop there. The second case is the search value greater than the value at the mid index? So is 59 greater than 25? The question is yes. So if it is greater than 25, it means that in our next search, we are now not interested in anything 25 and below. We are not interested now. We are interested in the other part of the array, or of the data structure, which is from 45 and now above. So if you realize is that from index 5, it is one step away from the mid. So to get now our left or our starting point, we get mid plus 1, and now 5 becomes our starting point. So our next starting point will be 5, which is basically mid plus 1. Now from 5, we maintain our right. So our right is 9, so we maintain that. So 5 and 9 give 14. So 14 by 2 is 7. So 7 are, now considering this part of the array, now 7 is our mid index. So our next mid point becomes 7. So now we go through again. The value at 7 is 63. So is 63 equal to to the search value, which is 59? No. Is 59 greater than 63? No. Is 59, which is the search value, less than 63? Yes. So which means that, take note, in this part of the array that we have now, 63 is our midpoint, and the search value is less. Our search value is less than 63, which means now we want to take the lower part of the array, the left side of the array. Remember, our new array is now beginning from 5 to 9. So if we are considering the left part of the array, it means that we want to forget about 63 and go a step below. So which means it will now be 5 to 6. So which means we are moving from 5 to mid minus 1. So we are not going to go 5 to 7 because we are not interested in 63. We are interested in the value before. So we are going to go to 5 to mid minus 1, which is 6. So the next point, we move from 5 to 6, which is 6 is mid minus 1. So 5 and 6 gives us 5.5, so we have 5. So we go through like that, dividing by a half and determining what is the next start and end points, or the left and right. Yeah. So now 5 is this. So it becomes our new mid. So you can now, this is the third time we are checking the mid. So this becomes our mid 3, mid index. So this becoming the mid index 5. So we again now check, is 45, which is the value at 5, equal to 59? No. Is it greater? Yes. So if it is greater, it means that we are interested on the right side part of the array. So we will continue like we are doing, and so it means we are now not interested in 45, or we are now interested in starting from the index above. So from a mid plus 1, which is 6. 6 to we maintain our right, and our right was 6. So we move from mid plus 1, which is 6, to 6. Okay, so now at this point we are here. All right, so 6 plus 6 is 6. So it's 12 divided by 2 is 6. So which means our next mid point is index 6. So with index 6, the value there is 59. So we test, is such value, which is 59, equal to the value at the mid index, which is 6? Yes. And at this point, we have found our item. So whenever the search value is equal to the value at the midpoint, or at the mid index, then we can consider ourselves to have found the value we are looking for, and we'll be returning the index of that value where we get it. So in this case, the index will be 6. Okay, so in the event, how about if we are searching for a value that does not exist, like 60? So we will go through. So we have a case where we are searching for a value, search value 60, which does not exist. So we'll go through the same process, and then when we reach at the point 6, then we'll go ahead and at this point, if we are searching for 60 and we are at 6, we consider, is 60 above, is it equal to this, is 60 equal to, which is our new search, is 60, which is our search value, equal to the value at the index 6, which is 59? No. Is it greater? Yes. So if it is greater, we will move our starting point to m mid plus 1. So mid plus 1 Remember now our starting point, left is 6 and right is 6. But now when we move the starting point to mid plus 1, we will get a start point, which is 7, and remember we maintain the right, which is 6. So at this point, the left will be greater than the right. If the left is greater than the right, then we know that we do not have that value that we are searching for. So that is it. And looking at the code, we basically doing the same thing. So we have a function which I just wrote, array, so which takes two values, array to be searched and search value. So I'm passing an array which is basically already sorted because we must be dealing with sorted array. So we're going to be searching for 59. So I will run it quickly and then we see the output. So 6. If you look at our data structure, you can see that our search value 59 is at index 6. If I put in, let's say 89, it is at index 9, which is index 9, which is that. So let me put a value that does not exist, a value like 60. 60, if I run 60, it will tell me such value does not exist. So what I'm doing here in the code is exactly what I explained. So the sorted array is basically what we passed here. So we are beginning with the left of 0 and the right of the length of the array minus 1. In this case, the length of the array is 10, and so our value will be 9, basically what we are getting here. Okay, so one thing we need to think about is that what is the stop condition? So we have to think about the stop input, outputs, then what is the stop condition? So we realize that whenever the left is greater than the right, then the value does not exist. So if the left is still less or equal to the right, then that means that the search can still go on. Okay, so at this point, our stop condition will be when the left is greater than the right. So the condition here will be as long as the left is still less or equal to the right, then we can still do it. So the first thing we do here is we get the middle index, then determine the middle value. Then we go now through our cases. Case number 1 was when the search value is the same as the middle value. We test that, and then we know once that happens, then we have found what we are looking for. So we return the index, which at that point will be the middle index. Case number 2, if the search value is greater than the middle index, then we move our starting point to middle index plus 1. So our new left will be, remember our right does not change, so our new left will be middle index plus 1. Case number 3 will be when such value is less than the middle value. So at this point our left does not change and our right changes to middle index minus 1. Case number 4 is if the left is greater than the right. If the left is greater than the right, then we know that the search value does not exist or such value is not found. So that's all. This is in a loop. So if I call the method and pass whatever I'm passing, then everything will be fine. So let me look for 25 and run, and it returns index 4. So if I count 0, 1, 2, 3, 4, and that is correct. This is the binary search. I first did the first attempt. It didn't work out, but I started the second attempt using this video by Jenny, and she was able to help me I'll go through it. Thank you so much. But the good thing is I made sure I wrote the code on my own before I could check it out. I just wanted to make sure that I will produce the code based on the understanding. All right, so that's it. Thank you.